My name is Patrice Seyed, Dr. Patrice Seyed. So this is data science. I've been teaching a data science course here at UMD for the past 9 years, either through this department or another one. I've been in this department for the last 3 or 4 years. I work in industry. I work for a health informatics company doing natural language processing on electronic health records. I use data analysis and data science in pretty much all aspects of my job. Okay, so let's talk about the actual course a little bit. So today is kind of introductory topics, intro to Python. Then we get into some statistics next week, some lightweight set theory and probability theory and that sort of thing. The week following, it's more about grappling with data. Data can just come in so many different formats. That I have some example and some exercises that we will kind of step through and have you do some parts of it in the week 3. We'll cover linear regression. The week following, we'll start to get into classification, specifically logistic regression. In the following week, including naive Bayes. I think also a hand-coded implementation of naive Bayes classifier in like 50 lines of code. Continue with decision trees, midterm prep, midterm, we've talked about this. Homework is not the first homework is not assigned until a little bit later. Project proposals are due before we dive into the midterm the following week. There's one particular lecture where I go into neural networks, and I saved that week to talk about the algorithm of gradient descent, which is relevant for logistic regression, and I can kind of provide you more information about it at that time, but not dive into the algorithm too deeply. You're not going to be held accountable for it in the midterm, but the way that you can kind of think of it is a logistic regression model is a very simple version of a neural network or a very basic neural network where you have the same idea of an input and you have an output layer that has an activation function based on the classification problem or regression problem that you're trying to solve. Why don't I just start the lecture? Data are everywhere. I get the idea that, data is the new gold or something like that. Data is the new oil or something like that. The thing is, most of the data that I work with is so noisy. It's so you have to really work to extrapolate the signal from the data to do anything useful for it. Usually if it's really good data, then it's worth something and it's behind firewalls at companies, that kind of thing. Or you've paid people to annotate the data for something. And Google had come up with such an amazing business model where they get so much good data on things that they want to be able to train on very, very easily. It's sort of interesting when you're doing the autofill, when you're typing in a Google search, you can kind of see what it's predicting to be the next word. They did that through machine learning models. So it's a very basic linguistic model to do that kind of thing. Here's some data. These are movies, and there are ratings to movies that viewers have given it, and the genre and the rating system, PG-13, so on and so forth. This is data too. Purchase history from a grocery store. So these types of data are fairly structured, not necessarily numeric, but even categorical in nature. But it's structured, right? You have clear instances of the data as rows, and columns as features or attributes of what each row represents. But data is also unstructured. That's where NLP kind of comes into it. You can do any kind of data analysis on unstructured data. Oftentimes you have to do things like normalize the data and translate it from words into a vector representation and take into account things like stop words and reducing the dimensionality of the data. Because if you think about it, the number of columns you might have is every word in the vocabulary of whatever language you're doing it on. So you have to think about that sort of thing as well.